All right, I'm going to start with the lesson for today. Um, I am going to start with the lesson for today, and the best way to understand what we are going to do is to know that Newton's law always applies. And Newton's law have three laws. Newton's first law, called inertia, Newton's second law that talks about mass and acceleration, as well as um, Newton's third law, which talks about action and reaction. Action and reaction has to do with if object A poses a force on B, B will pose the same but opposite force to B. So speaking of Newton's second law, F equals ma, force net equals mass times acceleration. Now if the acceleration is 0, we go back to Newton's first law. I'm going to do a few examples on Newton's law. So the first example is on the screen, but I'm struggling to reach the screen. All right. The first problem on the Newton's law, question number 1. Two blocks of a mass 6 kg and 4 kg respectively are connected by a weightless, inextensible string that runs over a light frictionless pulley, as indicated in the diagram below. The 6 kg block experiences a friction force of 9.5 and a coefficient of kinetic friction between the 4 kg block and the incline is 0.13. That's the information we are given. Now define frictional force. A frictional force is a resisting force of two objects sliding past each other. Let me write it down. It is a resisting force of two objects sliding past each other. Okay, what is a normal force? A normal force is a contact force. First of all, it is a contact. Frictional force is also a contact force. Force that is exerted by the surface. By the surface on an object on an object resting on the surface. Okay, they said draw a free body diagram for the 6 kilogram block. First of all, we are talking about contact forces. Contact forces, whenever there's contact, there's a force. Now, a free body diagram will be something like this. Let me see. Why did I do that? Okay. No problem. I'm having a problem here, but I'm gonna solve it. Okay. Okay, I'm gonna leave it like that. Okay. Now, what is the free body diagram? A free body diagram shows all the forces that are acting on the object. Now, the free body diagram for the object 6 kilogram will be like this. We have the normal, we'll have the gravitational force. Since the object has a mass, we'll write it as Fg, and a normal force. Since our box is resting on the surface, there will be a normal force. A normal force is a reaction pair. So if you have mastered Newton's third law, you will understand that whenever there's an action, there's a reaction. So normal force is a reaction force on the surface. What else do we have? There's a rope pulling to the right, so that's tension. Okay. Now, if you draw that free body diagram, you're getting all your 3 marks. That's 1 point, what number is it? 1.2. The 1.3, the free body diagram on the 4 kilogram block. 1.2. Now 1.3, we will have a free body diagram of a body resting on the surface. First of all, we have gravity, and we also have the normal force. Normal force is always perpendicular to the surface, always. Don't get it wrong. The other force is tension. Whenever there's a rope, there's tension. Now, there's keywords that you have to put in mind. The keywords like frictionless pulley. A frictionless pulley suggests that the tension on this rope will flow to this side as well, because the two pieces of rope are separated by a frictionless pulley. You must just cram it. It is what it is. Whenever you see a frictionless pulley, you must understand that the tension or the tensional force will flow. Okay, these are the two free body diagrams. Now we have to determine the angles. This angle, unfortunately, will always take the angle of the incline. Always. So that's 35 degrees. Okay, let's go to the next question. Calculate the frictional force of the 4 kilogram. In order for us to calculate these frictional forces, we have to use Newton's law of motion. We have to use Newton's law. And Newton's law is derived, Newton's law goes hand in hand with the free body diagram. So in order for us to solve the free body diagrams, we have to solve two dimensions. We have to solve for axis in the x direction and also in the y direction. I'm going to emphasize this, that whenever you have a tilted force, I do not want to see a tilted force. Whenever you have a tilted force or a force which is acting at an angle, you always have to break it down into components, please. So in order for us to break down, let's say if you have an applied force, to break it down into components, the force that forms part, the component that forms part of the angle given is given a cos theta component all the time, and then the other component is just fa sine theta. So for instance, if you have a situation like this, or let me call it pi. If you have a situation like that and you have a force, this component, the component that forms part of the angle, will be given a cos, always cos of the angle, f cos of the angle. Then the other one will be force sine of the angle. That's how it is. Okay, going back to the question. We know that we have to calculate, we have to resolve forces on the 4 kg block in order for us to calculate friction on the 4 kg block, because it forms part of those forces. So the other force that I forgot to put on both of them, in fact, is the frictional force. Frictional force. Frictional force. So the friction of 6 kg. And then here we also have a frictional force. Frictional force of a 4 kg. Okay. Now, in order to solve for friction on the 4 kg block. We have to consider the following. The first thing first, we have to choose the direction. We have to choose the direction. This is positive, and that is positive. Okay. Now, if we're solving, if we can call this direction perpendicular direction, and this one parallel direction. This is the direction which is parallel to the incline. Okay, let me solve the forces in the parallel direction. So we will have the following. We will have F net. We will have F net. This is Newton's second law, by the way. F net equals Fg sine of 35. Why is it sine of 35? I have said that if you are trying to resolve, the components, if you're trying to resolve the components, this angle also is 35. If you're trying to resolve the components, you will see that force of gravity is a tilted force. We have to resolve it into components that are going towards the parallel axis and the perpendicular axis and the parallel axis. So in order to do that, it will be sine Fg sine of 35 minus tension minus friction. And we all know that friction of the 4 kg is given by mu times normal force. Now, we don't have the normal force yet. In order for us to calculate the normal force, we do have mu. The mu in this case was given by 0.13. So to calculate the normal force, we have to resolve the forces in the perpendicular direction. Calculate the forces in the perpendicular direction. We know that normal force, since normal force is pointing upwards, to be positive, to be normal force minus normal force minus Fg cos of 35 is given by F net, which is equals to 0. Remember, in the perpendicular direction, F net is 0. So normal force will be given by Fg cos of 35, which is equals to mg cos 35, which will give us 4 times 9.8 times cos of 35. This will give us 32.11 newtons. So given that we have calculated the normal force from this equation, from equation 1, we know that frictional force 4 kg block is given by mu is 0.13 times 32.11, which is 4.17 newtons. Okay, going forward, let's go to the next question. Let's see if we have answered the question. Yes, we have calculated the frictional force. Now, what is the tension of the string? Now, in order to calculate the tension of the string, 1.4.2, in order for us to calculate the tension of the string, we need to calculate the forces that are involved on the 6 kilogram as well. Okay, let us solve the forces in the horizontal direction. Forces in the x. So on the 6 kg, forces in the x, we have positive tension minus friction. Any other force? No. It's given by force net in the x direction, which is equals to ma, which is mass of 6 kg times acceleration. I think we will all agree that if we divide by mass of by m 6 kg, if we divide, we will be left with acceleration equals t minus f, all divided by mass 6 kg. So this will be, do we have tension? Do we have tension? We don't have it yet. Don't have it yet. But the thing that we must understand is that when the system starts to move, the acceleration on the 6 kg and the acceleration on the 4 kg will be the same. So we all know that on the 4 kg, if we resolve forces in the parallel direction on the 4 kg in the parallel direction, we all know that FG sine of 35, FG sine of 35, which is the parallel component of force of gravity. Sine of 35 minus tension minus friction on 4 kg. All this is equals to mass of 4 kg times acceleration. Let's say this is equation 1. Okay. If I divide by mass of 4 kg, I will have m4 kg. I will have acceleration equals fg sine of 35 minus t minus f 4 kg, which is friction, all divided by okay. Now from here we can equate the two accelerations. So if we assume, not assume, given that if we replace 1 in equation 1 and 2, we will have the following. We'll have t minus f divided by the mass of 6 kg equals to fg sine of 35 sine of 35 minus t minus the friction of 4 kg all over mass of 4 kg. Okay, I'm just gonna substitute where I have to. Do we have tension? No. Do we have friction on 6 kg? Do we have friction on 6 kg? Minus. Unfortunately, we have. It was given. It's given by 9.5 divided by the mass 6. Fg is 4, which is mass times acceleration. 4 times 9.8 sine of 35 minus t is what we are looking for, minus friction at 4 kg. We calculated it to be 4.17. all divided by 4. Now, what we have will be, if I cross multiply, if I multiply both sides, if I multiply by 4, and multiply also by 6, so that I can get rid of 6 this side. Whatever I do on the other side, I can do it on the other side as well. 6 will cancel 6. Here 4 will cancel 4. So I will have t minus 9.5 is equals to 6 into 4 times 9.8 sine of 35 minus t, which is what we are looking for, minus 4.17. Now, for t, sorry, this is what we're supposed to have, 4 into t minus 9.5. Okay, so we'll have 4t, 4 times t, 4t, 4 times 9.5, it will be 38, is equals to 6 times 4 times 9.8 times sine of 35. We got 4.91. Then minus 6t minus 6 times 4.17. 6 times 4.17 will give us 25.02. Now, if we are solving this equation, we will have, if I take 6t, take it to the other side, and it will be 40 plus 4t plus 6t. The negative will change and becomes positive when it goes to the other side. The n will be left with 134.91 minus 25.03, and this will give us, let me see how much it will be, also plus 38. I forgot to add 38, because if you take 38 to the other side, it will give us that. So 10t is equals to 147.89. Now t is given by, if you divide both sides by 10, it will be 14.79. newtons. Okay. Did we answer the question? Let's see. Yes, we did. Now, what is the acceleration of the 4 kg block? Now, the acceleration of the 4 kg block, it will be as follows. 1.4, you see the question, so 1.4.3. Now, the acceleration of the block will be given by the following. We have already done the equations of acceleration before. So the other one was acceleration is given by t minus friction of 6 kg. We have already done these equations, divided by m of 6 kg. So this is equals to 14.79 minus a friction of what is it? By 9.5 divided by the mass of 6. This will give us 0.88. Or you can use the other equation, because we had two equations. The other one was F G of 4 kg times sine 35 minus T minus friction of 4 kg, and it was all over the mass of 4 kg. Now this was equals to 4 times 9.8 sine of 35 degrees minus 14.79 minus 4.17, and it's all over 6. Again, you will get 0.88 meters per second square, which is the same as this one. Okay, now another question. Let's go to the next question, which says, if the string is designed to only take 4 Newton, will the string break? Show your calculations. And that is 1.5. Will the string break? Let us see. 1.5. Unfortunately, the string will break because 4 newtons is less than 14.79 newtons. This is the tension that we calculated, and this is the allowable. Then you get all the marks. That's all they need. Yes, it will break. Will it break? Yes, it will. Because the calculated tension is greater than the allowed. Okay, 1.6, if the string breaks, calculate the acceleration of the 6 kg block. If the string breaks, we know that in order for us to calculate the forces, we need to have a free body diagram. Now the free body diagram will be as follows. You can't solve Newton's law without a free body diagram and resolving your forces in the x and the y's, or in the parallel and perpendicular direction in the case of an incline. So in our case, we will have the following. After breaking, there won't be tension no more. There will be friction. There will be normal force. There will be force of gravity. And again, this angle is 35 degrees. So this is what we're going to have. That's the free body diagram. Now, again, the force of gravity is a tilted force from the axis. From the axis in question, it is a tilted force. So if it's a tilted force, we have to resolve it into components. This component, which is Fg cos of 35, and the component in this direction, which is Fg sine of 35. Okay, now if we're using Newton's second law, we will know that if we are resolving in the parallel direction, this is the parallel direction. If we are resolving in the parallel direction, we'll know that Fg, which is positive, if this is the positive direction, if upwards is positive and right is positive also, we'll have Fg sine of theta minus friction equals mass times acceleration. Now acceleration is given by Fg is mass times gravity sine of 35 minus friction, all divided by the mass. In order to resolve this, we will have 4 times 9.8 sine of 35 minus 4.17 divided by 4. And fortunately, our answer for acceleration is 4.58 meters per second square. And that is all for Newton's law. The next question, which is question 2, it will be on projectile motion. So we're doing projectile motions. Without waste of time, I'm done for today, and I will see you guys in the next lesson. I'll see you guys in the next lesson, whereby I will be doing the second question, question 2, projectile motion.